Carotenoids are pigments found in plants that can provide numerous health benefits. However, consumption of carotenoids such as zeaxanthin and lutein are difficult to get in a standard American diet. These carotenoids are widely associated with eye and prenatal health as well as cognitive function. Popcorn, a popular Western snack food, has traces of carotenoids, where with modern breeding these concentrations can be amplified and increase its nutrient potential. High-yielding commercial lines of popcorn can be crossed with high-carotenoid hybrids of maize to result in high-carotenoid popcorn. These high-carotenoid varieties have an orange color which can give the popcorn a buttery appearance. This gives an advantage over standard white commercial varieties that must use artificial coloring and provide little nutritional value. During the process of popping popcorn, high temperatures and pressures cause the starch structures in the grain to gelatinize with the present water. These high pressures eventually cause the pericarp to burst, where the gelatinized starch puffs and expands into the well-known butterfly conformation of popcorn. Experimental orange breeding lines were created through taking orange maize donors and performing crosses and back crosses with commercial popcorn hybrids with the goal of retaining commercially important popping characteristics while still providing a nutritional advantage of high carotenoid content. The objectives of this experiment are to determine carotenoid profiles of selected commercial hybrids and orange popcorn breeding lines before and after popping, to quantify the color profile of popcorn in relation to carotenoid content in kernels and popped kernels, and to compare popping characteristics between selected orange lines and commercially available hybrids. Orange breeding lines have the competitive popping expansion values to commercial hybrids while still having the nutritional advantage of having high carotenoid content. This can be seen through the large majority of experimental breeding lines having an average popping expansion value of 27 milliliters per gram, commercial lines having a PE value of 29 milliliters per gram. After popping, the popped volume was measured in a large graduated cylinder where popping expansion was calculated as the ratio of popped volume in milliliters to the mass of kernels in grams. The second graph displays the nutritional advantage that the experimental breeding lines have compared to the commercially available lines through high carotenoid concentrations. Commercial lines have an average carotenoid value of 13 micrograms per gram, whereas the experimental orange breeding lines have an average total carotenoid value of 27 micrograms per gram, which is over twice as much carotenoid content. Experimental popcorn genotypes were chosen based on unique breeding profiles that were crossed onto commercial varieties. These lines were then ground and high-performance liquid chromatography was done to analyze pre-popping carotenoid content. This graph shows the relationship between mean total carotenoid content and mean popping expansion, where experimental lines have competitive popping expansion values of commercial lines with the nutritional advantage of having high carotenoid content. One thing to note on this graph is the variation between the experimental orange lines, but there is still segregation of traits that contributes to popping characteristics, where this may be resolved with an additional backcross in future breeding. There also needs to be future investigation on how high carotenoid popcorn affects consumer preference, where visual and flavor characteristics may influence the sensory experience of enjoying popcorn. Carotenoid pigments are associated with yellow, orange, and red colors. Colorimetry was performed on crushed popped samples to quantify visual color characteristics. Orange experimental breeding lines have higher A and B values indicating more of a red and yellow color than commercial inbreds. This variation in color can be seen in the pericarp of the kernel as well as the expanded starch in the popped kernel. Overall, in this experiment, we have created advanced breeding lines higher in carotenoids with a darker orange color with comparable popping expansion to commercial hybrids. There is still more to be done in the experiment in terms of fully screening the carotenoid content of experimental lines with high-performance liquid chromatography. There also needs to be further carotenoid analysis done on kernels after popping to measure the carotenoid degradation related to heat and storage, where bioavailability of carotenoids available to the consumer are quantified. There also needs to be an assessment for consumer preferences with orange popcorn varieties, where there can be further breeding done to cater to these sensory characteristics. Future generations of breeding through backcrosses with commercial lines are expected to decrease the variation in popping characteristics in experimental lines as well as cater to consumer preference, for one day, orange popcorn may be commercially available to you.